Hello, math students. Today we're going to continue working with exponents, but now we're going to have zero exponents and negative exponents. In class, I've already kind of hinted at least the zero exponents, but we're going to learn some of these rules today, and this is a really good day to probably take some notes. Maybe write some of these things down, so pause the video if you need to as we go through this. So when we're reading these essential questions, it's going to seem a little wordy. It says, how can you evaluate a non-zero number with an exponent of zero? They're just saying we're not going to use zero as the base. And how can you evaluate a non-zero number with a negative integer exponent? So instead of just having positive exponents today, we'll have zeros and negatives in addition to those. These problems all look very similar because we have quotients, fractions or division, and we got the same exponent in the numerator and in the denominator. So we've talked about these problems, and I've just basically said, okay, do we really need to do any work? These are fractions that have exactly the same thing in the numerator and the denominator. They're just going to cancel. Any fraction with the same thing at the top and bottom is just equal to 1. So we know that in the first example, we would subtract those exponents, because that's what we do with quotients. That gives us a 0. Same thing here, subtract the exponents, 6 to the 0, negative 3 to the 0, negative 4 to the 0 power. But we also said that each one of these, because there's the same thing on the top and bottom, that's equal to 1. What that's telling me is that 5 to the 0 is equal to 1, and 6 to the 0 is equal to 1, and negative 3 to the 0 is equal to 1, and negative 4 to the 0 is equal to 1, which really tells me that anything to the 0 power is equal to 1. Now that I know that, when I look at problems like these that have these 0 exponents in them, I know that 3 to the 0 power is equal to 1, and multiplying by 1 doesn't do anything. This part could really just be ignored in my problem. However, if I show that with my product of powers, I would add those exponents, and adding 0 doesn't do anything. Right? So ignoring that 3 to the 0 power and just having 3 to the 4th, or adding the exponents, I still get 3 to the 4th power. So on these problems, I can show you these product rules where we're adding the exponents, but I would also say, since anything to the 0 power is equal to 1, multiplying by 1 doesn't do anything, I could really take anything to the 0 power and just basically ignore it, and I will get my answers there. So this says, do these results support your definition? We just said anything to the 0 power is equal to 1. So yeah, that does support it, and that doesn't want to move. Oh my goodness, we are having issues with the smartboard today. I'm sorry. Okay. These now have negative exponents. But using what we already know, when we have a product of powers, when we're multiplying things with exponents, you know that we add the exponents. So 5 to the negative 3 and 5 to the 3rd, I would add those exponents, and I would get 5 to the 0 power, which we know is equal to 1. 6 to the 2nd and 6 to the negative 2nd, add the exponents, we get 6 to the 0. Again, we know that's equal to 1. Negative 3 to the 4th, negative 3 to the negative 4th, all of these are going to be the same, where I end up with something to the 0 power. These negative exponents, we're going to have one step today to figure out how to deal with those, how to get rid of those, and make them into positive exponents. So I'll be showing you that. Here's how we can kind of get an idea of what's going on with negative exponents. So in this place value chart, we've got this number, 3,452 and 867 thousandths, or 0.867. What I want you to be looking at is the exponents, right? So even if I start here in the tens place instead of at the very beginning, 10 to the 1st is just 10. 10 to the 2nd is 100. That's why it's in the hundreds place. 10 to the 3rd is 1,000. When I'm moving the other way, if I would start at the thousands, that's to the 3rd, hundreds is to the 2nd, tens is to the 1st. I'm talking about the power on the tens. So continuing that pattern, this would be to the 0 power, which makes sense because we said anything to the 0 power is equal to 1. So it's the ones place. Now, if we keep going after the decimal, decreasing our exponent by 1 every time, this is now a -1, and a -2, and a -3. Now, I want you to notice like the thousands place is 10 to the third, thousandths is 10 to the -3rd. These are, when we talk about decimals, it's really also related to fractions, which we're going to be using when we're doing this. Okay, so that pattern is going to be important. Here is like the actual rule. We already know the one for the 0 power. We figured that one out on our own. Any number to the 0 power is equal to 1. They also say right here, this is why at the very beginning it said a non-zero number to the 0 power. We are not going to try to trick you here. I'm not going to give you 0 to the 0 power. It is undefined. It's like a fraction with a 0 for a denominator. We just don't do it. It's undefined. Anything that's not 0 to the 0 power is going to be equal to 1. That's easy rule. I could give you some horrible looking, huge fraction problem. Have it all to the 0 power, boom, 1. Now, these negative exponents. A negative exponent is really the reciprocal, you guys know what a reciprocal is, that's when we flip a fraction over, of that same thing with the positive exponent. So if I have, for instance, 4 to the -2 power, that's the same as 4 to the 2nd power. Or I could have that flipped. If I had, I'm going to pick a different number instead of 4. If I had 1 over 5 to the -2 power, because that's a negative exponent, I would use the reciprocal to get it into a positive exponent. That would be a 5 to the 2nd power, and then be in the numerator now. Here's the thing. If you have a negative exponent, it's just not happy where it is. If it's in the denominator and it's negative, it wants to move into the numerator, and then it's positive. If it's in the numerator and it's got a negative exponent, it just wants to move into the denominator. So I'm going to talk about this like apartments, like an upstairs apartment and a downstairs apartment. Somebody's living in the downstairs apartment and they're not happy, like this 5 wasn't happy. Once it moves up to the upstairs apartment, it's happy. It just wants to move to the other part of the fraction. Oh, I think we skipped a slide. There we go. So 3 to the -4th power, again, it's really a fraction right now. This is really that. When I'm doing these problems, I'm usually going to circle anything with a negative exponent. Say, this is the thing that's not happy. It wants to move downstairs, and then it can be happy. When it moves down to the denominator, now it's 3 to the +4th power. I still need a numerator. That's going to be a 1. And then I could evaluate that. 3 to the 4th power is 81. In letter B, I have the same bases, -8.5 and -8.5. I add the exponents, that's the product of powers rule, and that gives me a 0 for an exponent. And we know anything to the 0 power, 1. In letter C, we've already done this, but I avoided negative exponents. The way that we have done this already is I would say, where are there more of those 2's? Oh, they're in the denominator. Okay, so I'm going to do this over here on the side. So I would have a denominator of 2, and there's 2 more. So this is what I get, which is 1/4. Now, if we talk about this in terms of negative exponents, we would subtract those exponents, which gives me 2 to the -2. And then we'd say, oh, that's not happy. It needs to move into the denominator. And there's my answer. I don't care which way you do this. Personally, I prefer this way. I like to just find where there's more of something and then figure out how many more. This works in this case. If I had only one thing with a negative exponent, then I just have to take care of my negative exponent and move things. Okay, this is evaluating, so we're going to actually be figuring out these numbers as well. But 4 to the -2, this is just not happy in the fraction. This wants to move into the denominator. So I would have 1 over 4 squared, which we know is going to be 1/16. -2 to the -5 power. Just not happy. Wants to move downstairs. Once it moves downstairs, I'll have 1 over -2 to the 5th power. Now I want you to be thinking about, is this going to be a positive or a negative answer? I'm going to have 5 of those negatives, so it'll be negative. 2 to the 5th power is 32, so this will be a negative 1 over 32. In number 3, I wouldn't bother making that 6 to the -8 happy. I would look at that and say, well, let's just add those exponents. -8 plus 8 is 0. And I know anything to the 0 power is 1. In number 4, again, you could certainly do this with our negative exponent rule and do 5 minus 6 and get a -1. Some people just logically want to go that route, and that's fine. I personally would rather say, well, I've got more of those -3's in the denominator. There's actually 1 more of them, and I need a numerator. Now, I'm not going to leave a 1 for an exponent, and if I don't have an exponent, I don't really need the parentheses. This is just going to turn out to be just -1/3. That negative can just kind of pull out in front of the whole fraction. In number 5, 2 options. Either you can make that 5 to the -4th happy, or we could just add those exponents together. I could have, and I can do this problem both ways, 1 over 5 to the 3rd power, because if I add the 7 and the -4, I get a 3. And 1 over 5 to the 3rd is 1 over 125. Or I could move this up to the numerator. And then I would have 1 over 5 to the 7th and 5 to the 4th over 1. Now I can look at this like one big fraction. Where do I have more 5's? On the bottom. How many more? 3. I get the exact same answer. And for number 6, I have this thing that's in the numerator that's got a negative exponent. I could make it happy. Or I could use my product rules and say, how many of those 4's do I really have in the numerator? When I add my exponents, I end up with a 2. And in the denominator, I have 4 to the 2nd. I've got the exact same thing on the top and the bottom. That's a 1. By the way, if you had, I'm going to switch colors to one kind of at the edge here, if I had taken this and moved it into the denominator to make it happy, I would have had 4 to the 5th on the top, I had a 4 to the 2nd on the bottom, and then I would move a 4 to the 3rd on the bottom, then that's a 4 to the 5th on the bottom, and then it's still the same thing on the top and bottom. In letter A, it's really tempting for students to just say this whole answer is 1, or -1 maybe, but it's not. The only thing that this 0 exponent is on is just the x. That part's equal to 1. So I'm really going to have -5 times 1, which is -5. In letter B, this is not happy. And again, a lot of people would try to just do the subtraction, and they would do -3 minus 5, and they'd get -8, and they'd have to still move that. I would just move anything that's got a negative exponent. Just move it downstairs. So I'm going to have a 9 on the top. I had a y to the 5th on the bottom, and then I'm going to move a y to the 3rd on the bottom, which is going to give me 9 over y to the 8th. This is the subtraction way. Again, in these kind of problems, be careful. Number 7 does not have parentheses. This is not saying that the entire thing is to the -2 power. Only the x has that exponent. This is not happy, and it wants to move into the denominator. When I do that, the 8 will stay in the numerator, and the x squared goes to the denominator. For number 8, this b to the 0 power, again, don't do more work than you need to. B to the 0 power is 1. Multiplying by 1 doesn't do anything. I wouldn't take the step to say 0 plus -10, because that doesn't do anything for us in terms of simplifying it. However, I can't leave a negative exponent. I haven't said this specifically, but negative exponents are not finished. They're not taken care of. We don't leave those in our answers. So this would need to move to the basement. So there wouldn't be anything left in the numerator, I'd leave a 1. And there's my exponent. And now it's happy. When I look at these z's, again, we could have done this problem already a while ago. I could ask, there's the 15 on the bottom, where are there more z's? On the bottom. How many more? 3. So I'm going to keep a 1 in the numerator. On these last two problems, I tried to get kind of as tricky as I possibly could. So here, let's look at the coefficients, the 10 and the 25. I could divide both of those by 5, just simplifying a fraction. That'll be a 2, that'll be a 5. So I'm going to do that, 2 and 5. Now I'm going to find everything that has a negative exponent. Anything with a negative exponent is not happy. This is where I would say I would just circle all the stuff that's going to move so I can see what moves and what stays. That's going to move, and that's going to move, and that's going to move. The only thing that stays where it is that single y in the numerator. So if you want to just leave that kind of first, you can. I like things to be alphabetical. So I had this x to the -4th. That one's going to go upstairs. And this x to the -8th is going to go downstairs. So I'll have an x to the 4th on the top and an x to the 8th on the bottom. The y that was there to start with, I'm going to leave that there. You can even put a 1 in there if you'd like. And then this y wants to move upstairs. So that'll be y to the 7th. And now I need to finish this. I need to use all of the other properties that we already know. So I keep the 2 on the top, 5 on the bottom. Now, looking at the x's, when I ask where are there more, on the bottom. How many more? 4. For all the y's, they're all on the top. I had 1 of those y's, 7 more y's gives me y to the 8th power. All right, this last one is kind of tricky with that negative exponent. Let's first clean up the fraction that I have inside there. The 4 and the 10, I could simplify that. That'd be a 2 and a 5. For the x's, I have more x's on the top, and there's 5 more on the top. Now, this is all to the -2 power. That -2 exponent is going to distribute onto everything in the numerator and in the denominator. That parenthesis says everybody gets that exponent. So this exponent goes onto the 2, and onto the x to the 5th, and onto the 5. So I'll have 2 to the -2 power, x to the power to a power we multiplied, and 5 to the -2. And now I want you to notice everybody's not happy. Everything has a negative exponent. Every single thing is going to move. I'm not even going to worry about evaluating those exponents yet. I'm just going to make everybody happy. 5 squared, now it's happy. 2 squared, happy. X to the 10th, happy. The last thing I would do then is 5 squared is 25. 2 squared is 4. Some of these problems you're going to notice are going to take a couple of steps. So today's worksheet, 0 and negative exponents worksheet, it is rather long. I admit that. I think that getting that much practice is good. However, if you're feeling overwhelmed, if it seems like it's too much, I'm okay if you just do the evens or the odds. If I can spell, that would be good, right? Odds. The answer key is in Schoology. If you're working through some of these and you're not getting them right, you might choose then to do a couple of extra and check it with the answer key, okay? When you're all done, there's going to be a learning check in Schoology, and let me know if you need any help.